Since the beginning of Data Protector, which was originally called OmniBack 2 back in the day, we at the support organization have been extensively using debugging mode to pinpoint the root cause of a problem or at least its background symptoms. Through thick and thin, debugging module is among the few that have no bugs, and sometimes we even use it as a diagnostic tool to help the customers address external issues, for instance, with networking or storage subsystems. Debugging is simple. In fact, collecting debug information is described in the troubleshooting guide in a chapter called Before Calling Support, to encourage the customers to actually provide that information before calling support. We've created this short tutorial. Every DP binary understands the option -debug. All the processes started by a debugged process are going to be debugged as well. For instance, if we run GUI in a debugging mode, everything will start from GUI. Every backup on media operation logs its activity into the debug files. It is always one file per process, one file per thread. The files are stored by default into /tmp on Unix and dpdata-home/tmp on Windows. You can see the path. Naming convention is the prefix ob2dbg is always there. It's the default one. The next field is their internal debugging session ID, helping you to identify debugs from the same session. Then comes the name of the process that logged into this file. Then the host name where that process was running. Then again some service information and the postfix which you can choose yourself. For instance, if you're having a problem with a SQL backup, you can specify the postfix sqlbkp.txt, which will help you identify the debugs from the specific failed SQL session. The default value is debug.txt. Now, to actually initiating the debugging mode. It's as simple as adding an option -debug to any db command and specifying how much information you want to collect, set by the range value and the postfix. Example. That's it. You can see the range set from 1 to 300. This is an optimal range for most support purposes, but sometimes we request the range 1-500 or even more. The range 1-500 covers about all of support needs. We will not go into debug levels details here. You can see the new debug file just generated in the tmp subdirectory. In the next scenario, if you wish to troubleshoot some failing interactive operation in GUI, you can either run GUI in debugging mode, run from CLA, like this. You can see the new debug files generated by GUI core and related processes, starting from here. You can also configure the already running GUI to enable debugging by simply by opening GUI as usually. Then go to File, Preferences. Yes, Debugging. You can see the two familiar fields, the range and the postfix, that is, file name. If you know exactly which process fails, like BSM or RMA, you can even specify its name in the debug module field, like this. But this is optional. Once these two options are set, check the radio button, use these settings for the next restart only, and hit relaunch GUI now. This new GUI is running in debugging mode until you close it. Reproduce the problem. Once the session is finished, save the session output and restart GUI. Restarting GUI once finished is very important, as continuously running debugging will overflow your file system in a matter of days, sometimes even hours. A good debug set, which will help the support organization identify the problem quickly, consists of the zip debug files from all the hosts involved in the failing job and the session output. You can read more about debugging in the troubleshooting guide, which I mentioned in the beginning. Here it is once again. Also, if you have some favorite debugging tricks or suggestions, please share yours in the comments. Thanks for your attention and have a nice productive day.